this video, we're going to look at geometry in the context of linear functions. This means we're going to look at things like distance, midpoint, gradient, and we're also going to look at things like parallel lines and perpendicular lines. For those who don't know me, my name is Chris Iannazoni. I used to work as an engineer for a defense company, and I've since left that to start a career in tutoring. I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. You can find the distance between any 2 points by using the distance equation. This equation actually comes from Pythagoras, where essentially all we're doing is finding the hypotenuse of a triangle. Let's have a look. In this example, we could show the distance between the 2 points by using this red line. There's also two other quantities that we will be interested in. The first is going to be the overall vertical distance of the 2 points. The first one starts at y equals 6, and the second one starts at y equals 7. That's a total vertical distance of 1. Now, we can also look at the horizontal distance. We start at x equals negative 2, and we end at x equals 4. That's a total horizontal distance of 6. Let's look at what we just created. We created a triangle. Specifically, a triangle where the only unknown length is that of the hypotenuse. From Pythagoras, we know that a squared plus b squared equals c squared, where c is the hypotenuse. So if we want to get the hypotenuse on its own, all we're going to do is square root both sides of this equation. Look familiar now? Going forward, we're just going to call it d instead of c, so it can stand for distance. All we're going to do now is plug in the terms that we found earlier, and thus achieve a distance of root 37. You don't have to build that triangle every single time you do a question like this. That was purely just for a visual aid. You can just directly sub in each of those points into your distance equation. It's also worth noting that it doesn't matter what you decide to be point 1 and what you decide to be point 2. You can flip the order around and still get the exact same result. The midpoint of any 2 points is calculated using the following equation. You can think of this just like taking the average of the 2 points. If you average the x values, you get the middle x value, and if you average the y values, you get the middle y value. So, using the same points from earlier, all we're going to do is just sub it into the midpoint equation. And just like before, it doesn't actually matter what you consider to be point 1 and what you consider to be point 2, you're still just going to get the exact same result. The gradient of any line is a measurement of slope, specifically slope as seen from left to right. If the slope is increasing from left to right, then the gradient is considered positive. If the slope is decreasing from left to right, then it's considered negative. The gradient is calculated using the rise over run equation. So basically, it's just another plug and play. So if you want to find the gradient of the line that connects those points from earlier, then all you're going to do is sub those points into the gradient equation and then simplify. We can see that the gradient is positive, which makes sense since we are rising from left to right. We also see that the gradient is only a small number. It's just 1 over 6, which also makes sense because the slope is quite shallow. It's not quite as steep as others would be. 2 or more lines are considered to be parallel if they all share the same gradient. A typical example of a question might be that you're given a linear equation and be asked to figure out a parallel line to that equation that also passes through some other point. The gradient of any linear function is equivalent to the coefficient of the x variable. So if we want to be parallel to this linear equation, then we also need to have a gradient of 3, or a coefficient of 3. So when we write out our linear equation, y equals mx plus c, we now know that m equals 3. All that's left now is to solve for c, and we can do that by subbing in a known point, which in this case is the point x equals 1, y equals 5. And when you rearrange and solve for c, you're going to get the solution c equals 2. Now, we just present all that information by completing the equation, y equals 3x plus 2. If you were to draw both of those equations on an axis, it would look like this. Notice that they have the same slope. Perpendicular lines are a very similar concept in that they're also defined by their gradient. Perpendicular lines differ ever so slightly because instead of wanting identical gradients, the gradients need to have what's known as a negative reciprocal relationship. That's just a fancy way to say, take whatever the original gradient was and do -1 divided by that gradient. In this example here, the original gradient was 3. So for our perpendicular line, we need our gradient to be -1 over 3. Once again, we're now in a situation where we need to solve for c, and we do it the exact same way, by subbing in the known point. This time, you sub in x equals 1 and y equals 2. If we graph this situation on an axis, it'll look like this. The key feature here is that the lines intersect at a 90-degree angle. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and stacks with detailed solutions. It's pretty cool. You should check it out. I'll see you there.